So in the last set of notes, we defined the log and we had the definition of the log. So it's really important that we are able to convert something from an exponential expression into a log expression. And we need to focus on the three parts to that expression. There is the base. They need to be a clearly defined base. There needs to be an exponent and an argument. Okay, and those are the only three pieces that can exist for us to be able to put it into a log form. There are some other useful definitions, and this is the idea that a log and exponent, they essentially undo each other. Here, an exponent and a log will undo each other. So if I have x inside a log and then we put that through an exponent, we get x back. Okay, same thing over here. So converting things into log expression, we need those three parts: an argument, base, and an exponent. Here we have a base, exponent, and argument, but we got an extra piece over here. So that extra piece has to be accommodated either into the base, the exponent, or the argument. Well, this is a plus. It cannot have anything to do with any of these parts over here. So the only thing that can happen here is we can put it to the other side, and we now have it in the argument part, which can accommodate that extra -2. So we can now, since we have our three parts, okay, we have our base, we have our exponent, and we have our argument, okay, that we can put that into our log form. So we're going to put it into log base A. Okay, the argument's going to be b minus 2, the whole thing, and that's going to equal 4x. And those are our three parts that show up in my, okay, so there's again my base, my exponent, it's my answer, and I have my argument inside the log. Okay, so for the next one here, we have y equals 7ab to the power x. Well, there's my base. That whole thing represents my base. Okay, not just the closest thing, but the whole thing because it's in brackets. There's my exponent. There's my argument. Well, this is nice and easy because I have those three parts clearly defined. I just have to make sure I put that whole thing into my base, and then my exponent log equals my exponent x. This is slightly different. Again, we talked about this in some examples before. This power is on the whole brackets. Okay? This power is not on 7ab. It's only on the b. So there's my base. Right? The base is not the whole thing. It's just b. Here, it's everything. Here, it's just the b. So I don't have a clearly defined base, argument, and exponent. I've got this extra 7a. So where does that 7a have to be accommodated? Well, we can't multiply into bases. Okay? We cannot somehow, squish it into exponents somehow. That's not really possible. So the only thing we can do here is we can move it to the argument side. Now we have our base, argument, and exponent. So I can convert this into an equivalent log expression. My base is b. My argument now is y over 7a. And my exponent is equal to x. Okay, so this one here, same thing. We need to have our base, argument, and exponent. Well, with this extra minus, this 2 minus, is not part of anything right now. So where can it be accommodated? Can we put it into the log with the exponent, or sorry, with the argument? Not really. Can this go into the base somehow? Well, that's not really reasonable. The only thing that can really happen here is we can put it with the other side. So I can just subtract 2 from both sides, and I get 2. Now this negative, that's, well, this is kind of odd. We don't know, how do we deal with that negative? Well, really this means a negative exponent. So if this is a negative exponent, well, we can put that negative on this side and just algebraically it's an equation, so it must be balanced. So we should be able to put it on that side as negative. And it does, since it's a negative log or a negative exponent, it shows up as a negative exponent on this side. Now we have this, our three parts again. We have our base, we have our exponent, we have our exponent here, and we have our argument. In this case, the argument is x. Okay, so we now can rewrite this with our base exponent equals the argument. Okay, so again, same idea going backwards now. We still need to have our base argument exponent pieces.